So in this lecture, we will start today with Z test of significance. In subsequent classes, we will be seeing about different other types of test of significance. But here we will start with Z test of significance. So what is Z test of significance? Coming to introduction, you can see this Z test of significance. It is also known as standard normal deviate. Standard normal deviate test of significance. About a standard normal deviate, I have also discussed this standard normal deviate topic when I was discussing about the normal distribution. So you just go back to that lecture and you get the idea of standard normal deviate. So this is this test, Z test of significance, is called as standard normal deviate test of significance. And this test is applicable when sample size is large. And what is large sample size? When sample size is equal to or more than 30. So when the sample size is equal to or more than 30, that kind of sample is called as large sample. Now when we are applying Z test of significance, so there are two conditions. First, that population should be normally distributed, and another condition is that sample size should be more than 30 or equal to 30. Why we need normally distributed population, or why large sample size is needed? Because when population is normally distributed and standard deviation is known, so this is very important. Standard deviation. Standard deviation is one of the population parameter that we have already studied when we were studying about the measures of dispersion. So when population is normally distributed and standard deviation is known, the sample mean will be normally distributed. When population is normally distributed and standard deviation is known, then sample means will be normally distributed. This is the statement made by central limit theorem. So what it wants to tell, why this Z test of significance is applicable in normally distributed sample or normally distributed population, because when population is normally distributed and standard deviation is known, the sample mean will also be normally distributed, and distribution of sample mean, normal distribution of sample mean is very necessary for application of Z test of significance. So in nutshell, you have to remember that Z test of significance is very much applicable for the population which is normally distributed. Then next is here you will see what is central limit theorem. So I have told you that sample mean will be normally distributed when population is normally distributed and standard deviation of the population is known. And this is a statement of central limit theorem. So it is better to know about the central limit theorem. What is central limit theorem? It is telling that the distribution of sampling distribution will be normal if n is large. When n is large, distribution will be normal. It is assumed, or central limit theorem states that when n is large, your sample distribution will be normally distributed. Even the shape of distribution is not bell shape. So that is why it is telling no matter what the shape of population is, even the shape of population is not bell shape, then also sample is normally distributed when your number of sample in a population is, or numbers of sample that you have taken is very large. So that is why the central limit theorem is telling the average of samples approximately normal distribution. So whatever samples, suppose you are taking large number of samples from a population. So large number of sample means, suppose you are taking 4 number of individuals from a group of 100 individuals. So every time if you are taking large number of samples, that means first time you have taken 4 individual, then another time you have drawn another sample of 4 other individual, then next time again another sample of 4 another individual. So like that you have drawn a large number of samples of different individual from that different combination of individual from that 100 a group of 100 individuals. So that means your sample, that sample that you have drawn is very large, and mean of the sample will be, the mean of these samples that you have drawn will be normally distributed. So when the sample is very large, this will follow normal distribution. This is the concept of central limit theorem. Now, till now I have told you, or we have discussed about the concept of Z test of distribution. So, if in nutshell, you have to remember that Z test is applicable when population is normally distributed. Now, another condition for application of Z test. So, in test of significance, you have to remember it very. This is very important point that you should remember what are the conditions where you are applying a particular test of significance. So, what is the condition for application of Z test? When sigma is known, that means sigma means standard deviation of the sample. When standard deviation of the population, when standard deviation of population is known, and when sample size is large. So these are the two conditions. Here you can see again from this table you can see this in first column it is given sample size. So sample size two portion, small sample that is less than 30 and large sample when sample size is more than 30, and another two condition that when population standard deviation is known and population standard deviation is unknown. So look at the first situation. When your sample size is small, and standard deviation is known, and that case you will apply Z test. So when population standard deviation is known, even your sample size is small, you have to apply Z test. Another condition, when sample size is small and population standard deviation is unknown, then you have to apply t-test. So about t-test we will discuss in the next lecture. Now coming to the third situation, when sample size is large and standard deviation, population standard deviation is also known, so definitely we will go for Z test. Then when sample size is large and standard deviation is unknown, so even only if sample size is large, then blindly we can go for Z test. Even population parameter, that is standard deviation of the population, is unknown. So this is the fourth condition, and now you know very well that whenever you are having large sample size or when population parameter is not known, then you can apply Z test. So first, if we do not know the population parameter, that is population standard deviation, so we have studied here that just see the condition fourth one, when sample size is large and population standard deviation is unknown. So if we do not know the population standard deviation, but sample estimate are from a large sample, then the sample estimate S or S square can be taken as sigma or sigma square. So even if you don't know the population parameter, that is population standard deviation, but the sample has been taken from the large population, or the sample size is very large, so the estimated standard deviation from sample, that is S or S square, will be considered as equal to the population standard deviation or population variance. So this is very important point. That is why even if you don't know the standard deviation of sample or population, then also you can apply Z test. Now, what are the utility of Z test? So what are the utility? Z test of significance is used to compare. So whenever we have to compare something, you have to think of Z test. So these two conditions when we are using Z test, a sample mean we have to compare what? A sample mean with population mean. So you have been given with the sample mean and population mean, and you want to test whether this particular sample mean and population mean is significantly different or they are one and same. Another comparison we want to make is the two sample mean. So we have two sample and we have mean of those two sample. Now we want to know whether the mean of these two samples are one and same or different. So this is called as this is where we are using Z test. Now first, the two tail and one tail Z test of significance. What are the two tail and one tail Z test of significance? I have already discussed this one tail and two tail test when I was discussing about the test of hypothesis. But here, just for refreshment, I have discussed among the two mean being compared. Suppose you are given with the two mean that you want to compare, population mean or sample mean. We do not have prior knowledge. We don't have prior knowledge. The prior knowledge, we don't know anything about the population or sample. So we don't have any prior knowledge to declare as to which one will be large and which one will be small, whether this will be large or small. So in such case, alternate hypothesis will be two-tail test. Why two-tail test? There will be two conditions. The alternate hypothesis, when mean will not be equal to mu, that is sample mean will not be equal to the population mean, or population mean and sample mean will not be two population mean two sample mean will not be equal. So if it is not equal, it may be either greater than or lesser than, but it is not equal. So here your rejection region may be on both the side, on upper side or lower side. That is why this will be coming under two-tail test. In this case, the rejection region lie on both the left as well as right tail of distribution. That is why it is here in such scenario you have to apply two-tail test. Now the second situation, however, when we are sure that one of our estimate or parameter value is either less than or more than. If it is either less than or more than, then we will go for one tail test of hypothesis. Why? You see here you will get two type of alternate hypothesis. One, sample mean is greater than population mean, or sample mean is lesser than population mean. So two kind of alternate hypothesis we are getting. Or if you are comparing two mean, then mean of one sample is greater than second mean, or mean of first sample is lesser than second mean. So this is how we are deciding whether we are going for one tail hypothesis testing or two tail hypothesis, and this is applicable for all other tests also. It is not only limited to jet test. Now here you can see two tail and one tail test, the table value, or rather you can say it critical value. Instead of table value, we can say it critical value. The critical value of Z at 5% and 1%, 5 and 1% level of significance in 2 and 1 tail table level of significance, we can see here at 5% level of significance in case of two tail hypothesis testing, the value is 1.96. At 1% it is 2.76. These are the critical value of normal distribution. When I was discussing about the normal distribution, then at that time in properties I have told you the critical value of the normal distribution graph. Similarly, in case of one tail, at 5% is 1.645 and 1% it is 2.326. So here you can, the first example is two tail test. This one is the left tail hypothesis testing, one tail test, and this is the right tail hypothesis testing. So now we will just see comparison of sample mean with the population mean. What is the test statistics? What is the proper test, or what formula you have to use while testing the hypothesis? When you are sure, now you have to apply Z test. So in that case, a single sample Z test is employed to determine whether or not a sample mean. Now you have to determine whether or not a sample with a mean X bar is derived from a population with mean of mu. So you are having a situation where you have to decide whether this sample is from that particular population or not. You have been given with the population mean and you are having sample mean. So now you have to decide whether the sample mean is equal to population mean or not. So in that case, you have to apply this formula. Here you can see Z test, Z is equal to X bar, that is sample mean minus population mean divided by standard error. Here this component you can see it is standard error, standard deviation divided by under root of total number of observation. So this is the formula for Z test. This formula you have to apply and you have to get the value of Z. Now, after getting the value of Z, you have to compare it with the critical value. You know, critical value at 5% level, it is 1.96 in case of two-tailed, and at 1% it is 2.57 or 58. So, this is how we are proceeding with the test. Now, we will see one example and then it will be very much clear to you. This example, you can see a random sample of 50 bunny buffalo has the lactation milk yield of 2200 kg. So, the number of sample is 50. So, you know 50 is coming into the large sample. So, this is a case of large sample, and population mean is given sample mean is given 2200. So, you are having 2200 sample mean, and population mean is 2000 kg. Population mean is 2000 kg. And another point, the standard deviation of population. So, we are having mean of the population and standard deviation of the population, that is sigma 500 kg. Now, alternate null hypothesis. What is null hypothesis? That this 50 buffalo sample is the part of population which is having mean of 2000 kg and standard deviation of 500 kg. But alternate hypothesis is what? The mean of the sample is not equal to 2000 kg. This 2200 kg is not equal to 2000 kg. So, this is our alternate hypothesis. Alternate hypothesis. Sorry, this is wrongly written here as 0. It should be H1. H1. Now, come to the test statistics. Z is equal to x bar minus mu, that is sample mean minus population mean divided by standard error. So, here 2200 minus 2000 divided by 500, and 500 is divided by under root of 50, that is sample size 50. So, by this way you are getting 2.8284. So, this is the value of Z, 2.824. Now, you remember the critical value of Z. So, at critical value of Z at 5% level is 1.96. So, this calculated value is greater than that critical value. So, that is why this Z test is the test of significance. Our interpretation is the critical value of two Z test of significance corresponding to alpha, that is level of significance at 5% is 1.96. So, what we will conclude? So, we will be seeing in the next slide. Here you can see now 1.96 is the critical value. 1.96 is the critical value, minus 2 plus. Your value is 2.8284, that is 2. We will take it approximately as 2.83. So, this is falling in the rejection region. Rejection region. This is the rejection region. So, this is falling in the rejection region. Now, you have to reject your null hypothesis. So, calculated value of Z is 2.824, which is more than the critical value of 1.96, which means that calculated Z is in the critical region of rejection of H0 at 5% level of significance. If you remember 1%, if you want to compare it at 1% level of significance, and you remember 1% level of significance, it was 2.57. So, even then, and that case also, we will reject the null hypothesis. So, this is how we have to test the hypothesis with Z test of significance. Now, comparison of two samples. So, in last example, we have seen comparison of population with the sample mean. Now, we have to compare the two sample mean. So, two sample mean, what is the given? Given is the n. This is one example. N is the number of sample. Number of observation, it is 100. So, 100 is the large sample. 100 means it is more than 30, so large sample. So, large sample, and now you have to compare. That means you have to go for Z test. So, here mean is given. Okay, just a minute. Summation xi is 250 kg, and for crossbreed it is 250 kg. For pattern body it is 170 kg, and variance is given 0.49 kg, and for pattern body it is 0.81 kg. So, this is the data that you have been given, and this is the test statistics for comparing two sample, that is x1 bar minus x2 bar. That means difference of two sample mean should be divided by the standard error of two sample that we are having. Now, this is the proper test that we have applied. So x bar is 2.5 kg because summation x was 250 kg. It should be divided by 100, so it will be 2.5 kg. x2 bar is 1.7 kg. Now you just put the value in this formula, 2.5 minus 1.7, and this is the way we are getting the standard error. Now the calculated value of this calculation you can do, and now we are getting the answer, calculated value of z, as 5. So the calculated value 5 is more than table value. So if you remember the table value at 1% level of significance, even at 1% level of significance, it is 2.576. That means the calculated value is greater than critical value. So again here also we will reject the null hypothesis and we will accept the alternate hypothesis. That means these two sample means are not one and same, they are different. So this is how we will do Z test for comparing either sample mean and population mean or two sample means. So in next lecture we will discuss how we will go for t-test, how and when we will go for t-test, what will be the test statistics for t-test. Thank you.